It is a WAV file with my name on it.
Let's see. Transition.
Common feature in police stations around the world.
So let's display swap.
Whoa. You have PowerPoint powers.
Well, I've been playing around with it. So here we go. I want to welcome everyone to the Data Architecture Virtual Chapter. Today I have invited and he accepted Jeremiah Peschka. I hope I said that right. And he's going to give a great presentation on designing a data strategy today. And I have some quick news here. I have a special code. It's there on the screen, VCSUM07, and it's going to save you some money if you want to go to the summit. So please use that code if you're going to pass summit. And I think it's $150, but don't quote me there. But it's some money, quite a bit of money. So use that code. So anyone wanting to go to pass summit, it's great. I mean, they got lots of sessions, a lot of people talking. And I'm actually going to be there this year. It's September the 26th. It's $18.95, and sure enough, it says there you can save $150 off registration. And use that code again. Coming up, they have what they call 24 hours of pass. And if you log on to that URL on September, well, you log in now, register, but then you can go to that URL, and they're giving all sorts of free training, 24 hours straight up, which is pretty amazing that people will be up 24 hours, you know, watching pass. I mean, I'm sure a lot of people will do it. Now, I want to talk about the virtual chapters. There's a lot of virtual chapters out there, and just if you want to go, there's something that interests you, like PowerShell or anything, any one of these chapters. Just log on to SQLpass.org. And you can sign up through the virtual chapter link and sign up, and you will get notifications on different webinars. Upcoming SQL Saturdays. Here's a list of the upcoming SQL Saturdays. So if you live near some of these locations, you log on to SQLSaturday.com, sign up, and you can go to one of these great sessions. I just went to one in Baton Rouge, and it was really great. I enjoyed it a lot. One of the last things I'm going to talk about right now is volunteering with Pass. So when you set up your profile in Pass, there's an option, and you can just say, I want to volunteer. And you can volunteer for different options and do things. And it's great to meet people, network, learn more stuff about SQL Server by volunteering. And finally, we have some awards, they give out every year. And if you know anybody you want to nominate for some awards, this is where you would go. You would go to these URLs at the bottom, and you can nominate someone that you think is doing a great job volunteering and giving their time and efforts to make Pass a better community. And with that, I'm done. I'm going to turn it over right now to Jeremiah, and let me see if we get this thing working good. I'm going to change the presenter. We'll try.
Technology is awesome. Oh, I made the presenter. I will click show my screen. It is showing the right screen, so you should be able to see a PowerPoint, and I'm going to hit play, and we'll get started. So, welcome friends to Designing a Data Strategy. I am your host, Jeremiah Peschka. I collect letters and put them after my name. As an aside, here's me and my coworkers having a dance party. We collect lots of stickers. That's what we jokingly call all of our various awards and certifications. The important one is the MVP award, just because it means I talk too much. So ask lots of questions, and I'll do my best to answer you. Uh-oh, I just broke everything. I want to be able to see my questions. All right. Hitting play, getting back to it. Okay, so you could call this presentation "Nobody Got Fired for Buying SQL Server." This is a bad joke based on an old saying, nobody got fired for buying IBM. Long ago in IT, if you wanted to do something, you just bought IBM hardware. Nowadays, we just use a SQL Server, and sometimes your data strategy needs to be a bit more flexible than that. So if you're doing things like saving a lot of XML or storing PDFs, you don't necessarily want to just keep dumping that stuff in SQL Server. Nobody got fired for making the choice of using SQL Server, but sometimes SQL Server may not be the best long-term choice for what you're doing. The big problem around this is, you've got a SQL server. The temptation is to just put everything in it, right? You put your PDFs in there, you put your XML documents in there, you put text files in there, you even put your cat pictures in there. This sort of works, but it gives us a lot of problems with how we manage SQL Server. Your backups get huge, those data files get huge. There's a lot of weird things that go on with how you have to consider indexing and querying. So, that's one issue. As SQL Server professionals, we see this a lot. Another issue that you see is you have a data problem, and developers see this a lot more than full-time DBAs do, but there are like 9 million databases on the market. And it can get really troublesome for people when you go out there and you try to figure out, well, what should I use? I have all these different databases. Maybe I should create something terrible that looks like this. You have a React pointing at a MongoDB that points at Hadoop, and there's Ruby and Amazon Web Services involved, and you just eventually hit the nevermind button and bail out because everything got so complicated you go back to being an employee at McDonald's. The one thing that a lot of folks don't stop to ask themselves is, what is the actual problem? What am I trying to solve? What's my issue here? And more importantly, a lot of people don't ask themselves, which database is right for my application? Amazon long ago needed to store data for the Amazon.com shopping cart. They realized that the way relational databases worked at the time, and really sort of still work now, it didn't solve their problem with having that shopping cart always be online. It didn't necessarily have to always be correct. Most people notice when they buy 40 cans of cat food instead of 4. So Amazon figured out a way to build a system that was right for their shopping cart application.
Jeremiah?
Yeah.
Hey, I hate to interrupt you. We're just seeing the dance screen with everyone dancing still. And we didn't know. Yes, and I hated to interrupt you, but
No, interrupt me. It's cool. This is important that we all learn from me. All right, let's try. Now you can see which database is right for my application?
No, I'm still seeing the main one with the people dancing.
All right, let me do this. Okay, I have stopped showing my screen.
Okay.
I will now show. Can you now see my screen?
I sure can. It says which database is right for my application.
Awesome. Okay.
Yeah. So, thank you.
We'll start here. I won't repeat myself. The pictures were unimportant. The words are the good part. So we have to ask ourselves the question: what database is right? Do I need SQL Server? Do I need something that just stores XML? At one job I worked at, we stored a lot of OCR, optical character recognition. We stored a lot of images of bills that we scanned. We didn't want to put those giant TIFF files inside SQL Server, so we actually had a specialized database appliance that we bought from EMC that was specifically designed for storing OCR'd TIFF images. So we chose the right product to store those images of bills. And it's all about finding the right database and asking the right questions around it. And answering that question of which database is right is actually really, really hard. And we're going to talk about how to get to that solution. And frequently, you're going to come back and say, well, SQL Server is the right database, and that's okay. I'm not saying you have to not use a SQL Server, but I'm saying you should ask these questions as you go through. So how do we do this? Option one is to not change anything. You look at your existing database and keep doing whatever you're doing, and maybe you hire consultants and you do a lot of hardware upgrades and you burn a giant pile of money in the parking lot, and your sand vendor comes and gives you a faster sand, and everything keeps getting better and better. And this is one way to do it. There are people who continue to scale this way, and it does work until you run out of servers that are of a certain size, you run out of rack space, or you run out of cache. Another option is to phone a friend. Ask a bunch of people what they're using and then pick the most common answer. They sort of call this hive mind decision making. This is, you just ask a lot of people, and whatever is the most common answer is what you use. This actually isn't bad, because at least if the people you know are using something, then you have a support network to go to find answers to your problems. It actually makes a lot of sense to use this methodology. You could do X because Y. I also call this designed by Hacker News. Someone else did it. They wrote a really cool presentation or video, and so you should do it too. Amazon's doing it, Microsoft does it, Twitter, Facebook, Instagram, whoever awesome new website does it, you might as well keep doing what they're doing. This isn't necessarily the best approach because these companies are solving problems that you may not have and you may never have. Just because Twitter has a particular problem, it doesn't mean that your data is of a structure or scale that you're going to run into those same problems as well. So you probably don't need some of the solutions that these bigger companies use. Just because something seems cool doesn't mean you should do it. The fourth solution, which is the one I prefer, is to do research. Use evidence, ask really difficult questions, and use those questions and build up a set of subjective and objective criteria to help you determine what the best way to solve that problem is. And obviously that is the one I favor because I use the biggest picture. I really like to use questions to get to that evidence that helps me make an effective decision. This is all about decision making and finding the right way to solve that problem of which database do I need. So one of the first things to do is to understand your workload. Can you answer these questions right now? How much data do you have? And how much of that data are you actively using? You may work with people who, I frequently work with folks where they say, well, we have 10 terabytes of data, but the end users actually only query the last 30 days of data, which is about 200 gigabytes of data. So, or, there's the small percentage in there. You want to make sure you know how much data you've got and how much is actively queried. If people are querying all of the data, that may make your choices very different, and it does change how you have to approach that data. You also have to know how fast the data is being added to your system and also how fast you're removing data. These two things really do make a big difference. Relational databases do a pretty good job of helping you add and remove data constantly. Some other systems, removing things is a bit trickier, and adding things may actually be even easier than it is in SQL Server. So there's a lot of different things that you have to take into account about how much data you have, how much that data can change, and how often you access that data. What do the queries look like? Which queries are you running the most often? What's the shape of those queries? And by shape, it's sort of is it a transactional query? Are you pulling back one thing at a time? Are you just getting an entire order? You're saving an entire order. You're updating one address. Or are you doing big reporting queries that have to span many different types of things? And you're looking at, say, average credit card spend per zip code by group by credit card type. So you may have to be doing more complex things that need to use a lot of data from a lot of different sources or different types of data. Being able to answer these questions helps you decide what that database you're going to use looks like. Also, think about how much data you've got. Memory is a lot cheaper than anything else that you can do. These prices are about 6 months old now. They were correct then. They're still roughly correct now. But if you look at it, you can fill a database server with memory, these 16 gigabyte memory sticks, for about $11,000. And in a few months, I've heard rumors that we're going to have 64 gigabyte memory sticks. So you could feasibly have a database server with 3 or even 6 terabytes of RAM. And for the most part, you don't really have crazy data problems until you run out of memory for your workload. So just remember that sometimes you can actually solve your problem by using the corporate card and visiting newegg.com and just buying a lot of memory for your SQL Server. The sweet spot here is when you can fit your frequently accessed data, your active data set, when you can fit that in memory, that's the sweet spot. If all of your line of business data fits in memory, you can do interesting things like buy a second server for reporting, offload your reporting to some other system, make everyone happier by even just using a secondary in an always-on availability group, or having a copy of your data in a data warehouse for people to query. That way your line of business data, your active operational data, stays small and active and in RAM, and then big terrible queries happen on some other system. that you can optimize for those big, terrible queries, and users have the expectation that it may take seconds to minutes to get their data back versus milliseconds to seconds to get the data back. Everyone will be much happier if you can separate reporting from line of business. A lot of people sort of fall into the trap very early on of, I need something very, very customized and special. I need to have some very attractive, shiny, brand new database that's never been seen before, when in reality, if you split data out between active and reporting data, you suddenly solve almost all or even all of your problems. Make sure you do understand that rate of change. You know, a read-heavy workload is something that I consider between 1 and 10% right. Everything else is reads. A mixed workload is about 10 to 40% right, and a write-heavy workload is 40% or more writes. And know what you're doing, because different databases do excel under different conditions. You know, SQL Server analysis services, for instance, you don't want to just keep constantly changing data in there because of how cubes are built. You know, you want that to be a largely read workload. SQL Server, the relational engine, does better with more writes, and some other database products do incredibly well when you're even at 40, 50, 60, or even 80% write workload. These things keep chugging along very, very effectively. You also want to look at how that data changes, because different systems respond in different ways. You know, is it always brand new data where you're just adding new rows to the end? Is it updates or is it deletes? Even within SQL Server itself, this is actually becoming a really important question. With things like read committed snapshot isolation or snapshot isolation, you know, updates create new versions of rows, and deletes create new. You have to hang on to that deleted row until reading transactions are done. Or with Hackathon, with the in-memory feature, updates actually create a completely separate copy of the row. So there will be 2 copies of your row in memory until the old copies are cleaned out by a background process. And deletes just write a tombstone message. They don't delete all the old copies of the row. So knowing how your data changes helps you pick effective technologies and size those technologies effectively. You can't just throw something in. There is no such thing as a drop-in replacement for another technology platform. You have to make difficult choices. And again, we talked about this a little bit. What is your query pattern? What's that query shape? How often are they run? What do the queries look like? Is it a narrow query for a single object? And here I use the word object not as in a SQL Server object like an index or a table, but more object as in a business object, being an order or the contents of one shopping cart. So are your queries looking for one object at a time? Are you looking at maybe an object graph like a shopping cart and the user associated with that shopping cart? Is it ad hoc queries where users can define queries all the time? Or is it more structured where there are rigid reports being used? Knowing what these look like really helps you change or choose the most effective database. Some database systems, SQL Server, does incredibly well with ad hoc queries. But the more flexible the system gets, you know, SQL Server has a very rigid schema, and as things get more flexible, say a key value database, ad hoc querying becomes very difficult because you don't know what's in that key value, so you can't really do crazy ad hoc queries across it. So I want to talk a bit about subjective criteria. I mentioned at the beginning that there's 2 sets of criteria you want to use to help you make this decision a lot more effectively. One is subjective criteria, and then we'll get to objective criteria as we move forward. Subjective criteria is, first off, you want to choose positive subjective criteria. This means that things that, while they're subjective, while they're based on opinions and human beings who are incredibly fallible, that subjectivity can still be verified. Example, subjective but useless, ease of installation, right? I saw a video a long time ago where somebody talked about how PostgreSQL was much better than SQL Server because you could install it via a command line script, whereas SQL Server you had to click through a wizard. Well, anything can be made automatic with enough scripting. You can't do a command line install of SQL Server. So the fact that the scripting is present is important, but the fact that a wizard is required to make the install, that's not as important. Now, how easy those tools are to use, that's important, and the fact that you can script an install of SQL Server, that's important. Another thing is ease of operations, which is somewhat of a useless criteria. True mastery makes anything look easy. You sit and you watch people, you watch Kendra Little tune indexes, and I just say, okay, you really have this down. You are a master. You make this look simple to me. And anyone who's really mastered something can make it look simple. But what's more important than things looking easy is that there's a quick learning curve. If you can easily get into something and learn it, that's the way to go. Checkers is a very easy game to get to learn. Three-dimensional chess from Star Trek, very difficult to learn. There's a reason why people don't play three-dimensional chess. It's really, really hard. It's a very harsh learning curve. So just make sure you know that the question you're asking is the right question. Don't ask, is it easy to do operations on a system, but more so ask yourself, is it easy to learn how to work with this system? SQL Server is great because it does have a fairly quick learning curve, so that is much more important than it being easy to use. Some more useful criteria is how friendly is a system to a developer? Are there well-published and well-documented APIs? Is there something like MSDN? Are there drivers? Are there people who work for that company who will come and talk to you and help you figure out the most effective way to use their product? Azure, is great, but would Azure be as great as it is without people at Microsoft to help you understand how to use it? Probably not. Likewise, a community is important. Is there a user group? Is there a yearly conference around whatever technology you're looking at? SQL Server has one of the strongest, most passionate communities I've seen. Don't necessarily judge other products' communities by SQL Server. Not everybody has as amazing of a community as we do, but just look for, are there user groups? Are there meetups? Is there somewhere I can go to learn about this? Also, not every vendor publishes a roadmap. You don't always know what new features are coming out, so make sure you do know what's coming down the horizon. This is really valuable for a couple of reasons, one of which is you just don't want to be surprised. Another one is you don't necessarily want to have to build a lot of functionality only to have a new feature of the product change everything that you have to do. Make sure you can automate it. And again, how hard is it to automate? Is it easy? Is it difficult? And is there documentation available? Can you Google for a solution and find it on the vendor's website? You don't necessarily want to find the solution on a blog. I mean, if it's on a blog and on the vendor's website, that's okay, but you don't want the primary source of documentation for any product you're going to use in production to be someone else's blog. Now, those were subjective criteria. You can argue about them. Objective criteria, on the other hand, are facts, where any third party, given the same information, should be able to come to the same conclusion. You could take the same information, give it to somebody in, say, the accounting department, and based on that information you give them, they should be able to come to the same conclusion as you. These are going to be things like benchmark performance. There are some common open source benchmarks which are great for evaluating different databases. YCSB is the Yahoo Cloud Standard Benchmark. AmpLab comes out of the University of California at Berkeley. Looking at these benchmarks, they both define different ways for a database to perform. In SQL Server, we also have TPC benchmarks. Does it support your chosen programming language? You want to make sure your developers can work with whatever product you're using. Also, does this database product, is it stable? In the early life cycle of any given product, APIs and syntax change a lot. So you want to make sure that whatever product you're looking at using in production, it's stable and it's not going to change frequently. You don't want to have your team rewriting things constantly, so just make sure that that syntax that they're going to have to use is stable. Look for features and functionality, figure out what you might have to implement yourself versus what somebody else has to do for you. A common example of this is table partitioning. Different relational databases even implement this differently, and there's a different amount of work required depending on the database that you use. This spectrum can be as easy as, partition on date, and as difficult as having to create views on top of many tables. SQL Server lives somewhere in the middle of this spectrum of super easy to it's kind of a pain in my backside. The thing to also think about is how durable is the database? Does it provide the guarantees that you need to keep your data safe on disk? Different database products do this differently. So make sure you know how this is going to work. And can you figure out why it's slow? Can you monitor the product? Do you know what's going on? Can you get insight into what's happening? So those criteria define the behaviors. So by analyzing the criteria of different products or analyzing what we need, we can determine how our choice has to behave when we move it into production. We can say this has to have the data on disk in a certain amount of time. We have to be able to query it in a certain way. How do we know what we need? Well, this is tricky. What do you need, right? Sometimes folks start talking about ACID, like I need ACID compliance, C is an ACID. This gives you global state consistency guarantees. That's a mouthful, but this really means things like number of cars produced has to be less than or equal to the number of engines purchased. This may or may not happen as a part of the database engine itself. This may require more business level logic, but that C and ACID is sort of, think of it as a consistency global state guarantee. You have strong guarantees over collections of things that define a total system state. Your total count of personnel records should be the total number of people that you have hired over all time. You shouldn't have records for employees that you've never hired. And when you start talking about consistency in other ways too, you see as an eventual consistency where state eventually converges. This is, say, transactional replication. Eventually that replica will catch up, and I'm okay with it maybe being behind for a little bit because something happened on the network and somebody was downloading a lot of cat pictures in HR. These applications can typically survive a single server failure. If the publisher is down for a period of time, that's okay because the subscriber can still be read from. Eventually that publisher will come back online and then the subscriber will catch up. You do have a weaker guarantee of system state. Reads from that secondary can occasionally be stale, but you have a stronger guarantee that the system will be online. So a lot of this, as you think about how you deploy and which applications, which databases you choose to deploy on, think about, do I need strong global state, or can I have some fuzziness about state, but I know that things will be online and available? Finances, we typically want to know exactly what it means. It's strong global state. A count of 24 packs of toilet paper available in Costco right now, I'm okay with that being off by 5. So just make sure you know which of these things is appropriate. And more importantly, ask yourself what users need, right? Think about application consistency. This has nothing to do with ACID or the CAP theorem or eventual consistency or strong consistency or anything else you can think of as a reason, a technical reason to not use something. But think about features. And application consistency is just a feature. What do the users need to see? What is important to those end users? And this is really the only thing that matters. As long as the users are happy, everyone else can be happy. And application consistency is a mix of features and service level agreements. A video should not be public until it's been transcoded into multiple formats. When you upload something to YouTube or Vimeo, that video isn't visible to the public until people can see it in a variety of resolutions, whether they're on a computer or a phone. People just can't see it in one place but not another. That's great. Or maybe your analytics process should complete in less than 4 hours, and it should be fault tolerant. So if it fails, it rolls back, and it should be correct. So it shouldn't fail in the middle. Things like account balances, your bank shows you the correct value as of the last time they reconciled, and it also has to present a consistent view of those unreconciled transactions. So a lot of the time, your bank will show you, transactions that haven't been processed yet, but that it's been made aware of. And you'll notice that those don't disappear from the list, but new things can come in at any moment in time. You don't necessarily have to show all the unprocessed and unreconciled transactions, but that view does have to be consistent. Once something hits the queue to be processed and reconciled, it stays there and it's visible to you. So think about what features people need to see. Filling out a story card. As an end user, I need to view videos when they're all ready because internet. And you can sort of think of this as like a pair of boxes, right? The box is what the user sees, but the functionality can come from anywhere. It doesn't matter how much or how little of that functionality comes from the application versus the database, as long as what the user sees is consistent. It doesn't matter to me how this mug gets here, as long as it's a mug that can hold coffee. That's the important part. I don't care if it's metal or ceramic or plastic. As long as it holds my coffee, that's the important thing. Just make sure you get there. You may have to put more code in the application. That's okay. Developers actually like that kind of thing. They think it's challenging and fun, whereas we would just rather that the database worked. And we can get back to doing what we do best, which is looking at DBA reactions. So think about this, right? If users need to be able to customize a table with columns, and there's no way to predict or what the users are going to add or what data type it could be, what would you do to solve this problem? Let's think about that for another 3, 2, 1. And there's a couple of options. In SQL Server, you could use an entity attribute value database schema, which is where you just sort of say object 12 has a thing, and thing contains the value foo. Jeremiah has a coffee cup with a logo on it. This can be complex to model. Querying on this can be really difficult. Some people like it, some people don't. You could maybe use XML. You just sort of have, I have an XML thing I'm going to save. You might be tempted to use the sparse column feature of SQL Server, where you just keep adding extra columns on the table and mark them all as sparse because not all users can have them. You may also use something called a wide column database, which HBase or Cassandra are two examples of it, where you can define columns on the fly. And it's just sort of a loose mapping of keys to values, and they're a little weird to think about, but you can just sort of keep defining columns on the fly as users are using the data. This gives you tremendous flexibility, but you are limited in some of the ways you can query the data. Or maybe use a document database like MongoDB, which does change a lot of aspects of how you store and query data, but it gives you an incredible XML-like flexibility in how that data is stored on disk, and you can change how you store data from one database object, one database item to the next. We have to get these answers, so how do we know which questions to ask? The first and most important question, or one of the first questions you can come up with, rather, is what is important to your application? What do users want to see? What does that application have to do? And as you start thinking about this, ask yourself, what is important to the users? Even as DBAs, we do have users of our application. That may be the developers, it may be the developer's lead architect, or there may be business users we can talk to. And this is your opportunity to get with those people and talk to them and figure out how to make things shine, how to make it wonderful from a data perspective. This is our chance to interact with those folks and win them over instead of just being the database administrator who's constantly grumpy. And keep these in mind, right? Getting the right answer really does mean you've got to go out and talk to your users. Think about the application and think about those end users. The way you always solve a problem in the past may not be the way you're going to keep solving problems in the future. There are a lot of different tools out there, and they solve a lot of different problems. So keep that in mind as you're looking at things and thinking about products to use. This is not about what your peers are doing or what the people across town are doing. This is about solving your problems. Sometimes SQL Server is not the right tool. Sometimes it is the right tool. And just make sure you're asking the right questions so that you can answer them effectively. You don't want to just default to something because it's what you've always done. So what are the right questions? Make sure that you have objective questions that can be backed up by facts. Those objective questions should be easily measured and tested. And the upside of objective questions is you can mitigate them by money, technology, or time. If the objective question, or the answer comes down to we need to provide so many IOPS per second, or so many IOPS, or so much disk throughput, you can mitigate that with money by buying faster disks or more disks. You can also switch your technology and maybe keep the same count of disks, but use solid-state disks. There's a lot of things that you can do to solve that problem. Subjective questions are things that are a little bit more difficult to answer. They're fuzzier. As technology people, we probably like these a lot less than objective questions. Subjective questions are typically mitigated by people. You say, well, we need to run this, and it only runs on Linux, so we need a Linux admin. We need to use more SQL Server, so we need Windows people. These are subjective questions. You do have to weigh them more carefully because it's very easy to let your own biases really twist the answer to these questions. Of course, we need to store all of the data in SQL Server with file stream because it's in SQL Server, and that's what we do, right? That's where I store my personal photo collection. Don't keep looking at these things and say to yourself one day, I'll become a heart surgeon just in case I have a heart attack. Don't become an expert in something just because you think it sounds cool and you want to use it. If you don't know anyone who is an expert in a technology, really think about what that tells you about the technology. Be very, very careful about becoming the expert in something because you want to use it. We don't have to be the expert in everything that we use, but you do at least have to know where to find that expert. Some sample questions, right? So I mentioned lots of questions. Do you have an existing uptime requirement? Different products handle availability very differently. For example, cluster failover is not instantaneous. SQL Server always on availability group failover is not instant. So make sure you know what is that uptime requirement. How long can I be down for? And do you even have a performance SLA? These could be equally important. How fast do queries have to run? Amazon has done a bunch of studies, for example, about how many customers they lose based on the milliseconds of page response time. And so they know how fast that page has to load before people give up and stop spending money. You might measure your read and write latencies. You may measure number of reads from disk and say queries that run over 1,000 reads have to be run on the reporting server, which is 10 minutes behind. And you have these particular performance SLAs that you can use to address it. And when people need live data, you find ways to make that query fast or they hit the reporting server. How long do you keep data around? How fast do you add new data? And how long do you need to sustain that level of growth? If you're always adding 200 gigabytes of data a day over the course of a year, that's a pretty difficult level of growth to sustain. But if you can delete that data after 30 days, that's a different level of growth that's a lot easier to sustain. Answer the hard questions about data lifecycle. You'll be very happy when you do. What technologies are you currently using? We're here. This is a past virtual chapter, so I suspect it's probably SQL Server and maybe some .NET. But also ask, what are your developers comfortable with? Maybe they also are really comfortable with JavaScript, and maybe they want to try some Node.js. What do they know how to use, and what do they want to learn? When you start looking at adding new features to your product, to the products you support, this is a fun time to actually think, what do I want to learn? What do my developers want to learn? How can we maybe mesh these goals together so that we can all learn some cool stuff while we add more to the business? Business users get happy, and when they get new features and functionality, if the dev team and you're doing something exciting and new, this can be really cool. And how should the application behave? Make sure you know this, right? What are my data access patterns? Am I doing a lot of reads? Am I doing a lot of writes? When I do read the data, what's the query shape look like? Am I reading one row at a time? Am I reading one thing at a time? One order, one HR record? Is it transactional, or is it a decision support system, or maybe it even is OLAP. What am I doing? How does this act? And what are the core features of my application? One of the interesting things is when you start looking at applications, very few applications have a lot of ad hoc requirement. Most applications actually have a fairly rigid core set of queries that people answer or people ask, and typically even reporting is done fairly rigidly. Most people just don't want to make up their own questions. So sometimes you can narrow it down. There may only be a very small number of ways people interact with your data. Also, ask yourself, how does this application have to behave? What happens when there's a runaway query? Should you be able to kill it? Early on in my career, when I was writing reports, I used to have to sheepishly pick up the phone and call my Oracle admin and say, hey, Alex, I ran a bad query again. It's been going for 20 minutes on the production machine. Can you kill it, please? It's embarrassing to do, but you need to have a way to kill off these runaway queries. Or maybe ask yourself, how should the application behave when user volume doubles? What if we get double the users overnight? Does this thing still have to respond at the same exact speed? And how should we handle invalid data? Should those writes fail? Should we just save the bad data so someone can deal with it later? Knowing how that application behaves helps you as a database person figure out the correct way that the database has to respond. And once you know what that behavior at the database level looks like, then you can actually make a very effective choice about which database you use to solve these problems. And an infamous example of this is folks try to use SQL Server peer-to-peer replication. They used to use this for handling sort of a scale-out load. One of the issues that can happen in peer-to-peer replication, or even with updatable subscribers, is if you update data in two places at about the same time, you can get write conflicts. You may have two versions of a row, and how do you handle having multiple versions of a row? Sometimes you use last writer wins. Sometimes you may have a custom store procedure that changes the data in flight. So knowing how you handle things like that is also really important. So to sort of sum this up, because I know you got sandwiches to finish eating, picking the database is really hard.
Sorry.
No, you can laugh at me, that's cool. A lot of this comes down to understanding application behavior, right? What is my performance SLA? What is my uptime SLA? Different tools do different things. I worked with somebody maybe about a year ago who currently were able to get 99.9% uptime with SQL Server through some very, very aggressive management practices. Unfortunately, the business wanted 4 or 5 nines of uptime, and so they had to start looking at different options. They said, okay, we know we can't do this anymore with SQL Server. How do we reach 5 nines of uptime? And these are really important things to do. Features are actually a lot less important than these performance and uptime guarantees, because you can write code to solve almost any problem. Just keep that in mind. Developers love writing code. It's their job. Define a set of criteria that you're going to use and that are important to your team for picking a database, right? Make sure you use objective criteria, facts. What do these facts have to be? And have subjective criteria. These are opinions. People get involved, right? There is some fuzziness between these two. Subjective is much more opinion-based. Objective is just pure facts. And make sure you actually dig down and keep asking hard questions and iterating through. This is not an easy thing to do. It is very, very easy to just default to SQL Server and say, yeah, got it, use SQL Server. Sometimes you don't necessarily need to use SQL Server. Sometimes you may use a MongoDB or you may use a Hadoop. And that's okay, because they are databases and we are database administrators. And so as long as we keep having databases, we do have jobs. And we may just have to learn a few new techniques, but it's still job security as long as people want to store data. And I want to say thank you guys very much for attending and for eating sandwiches with me. I appreciate it.
You're welcome. Thank you. We have a few questions. If you have a moment, we can go over them.
I do. I didn't see any come through.
Oh, yeah, they're on the question and answer tab.
I bet you didn't make me an organizer.
Oh, let's see if I can still do that.
If you right-click on my name, she'll make me an organizer.
You got it. Oh, let's see.
I bet that's why.
Oh, no wonder. Oh.
If not, you can just read me questions and I'll answer them.
Well, let's see if I can get this fixed.
Where'd you get that amazing shirt? At a conference. No, at a concert, actually.
Okay. Hopefully you can see them now. Try.
Is it started? Yes. Is there a slide deck? Sort of. Do I ever use weighting to help quantify the subjective criteria? So I'm gonna let's see if we can hop back to some of the subjective criteria. And yes, in short, I do, because there are different things that are of different levels of importance. You know, if you are okay, for example, with writing your own database driver for something, you may weight that a lot lighter than just having somebody available at the vendor who can help you solve pattern problems rather than nitty-gritty technical details. So I definitely would weight the subjective answers according to what is important to your team. Some people find certain things to be far more important. So absolutely, I would definitely weighting to help quantify criteria. Do I use any tools to check for query shape? How would it help? Basically, any kind of tool that you would use to just monitor queries as they're running, server-side trace, extended events, any monitoring software, that will be helpful for looking at the shape of a query. Another question I have is, we store Excel in SQL Server. Is this a good approach? It's an approach. If it's how you're doing it, that's okay. There's a lot of technical issues with storing lob data in SQL Server. What a lot of people do is they just sort of store a pointer to a network share and then have the applications read from the network share. That tends to get your lob data, your big binary data, out of the SQL Server. That would be the end.
Yeah.
The alternative I used, just so you know, kind viewer, I used something called an EMC Centera, which is not a lightweight or cheap device, but it does let you store just about anything in it, and it does a really good job of storing large chunks of stuff.
I think we have one at work. I've never had a chance to use it, but I think we have one where I work.
Yeah, it's kind of a cool thing. It doesn't let you modify documents, interestingly. So whenever you save a new version of the document, it actually just gives you back a key for the document. So that way you're never changing anything on disk. And the upside is you can keep saving new versions of documents and see the historical record over time, which is awesome for things like legal or HR.
Yeah, that's probably why we have it. Okay.
Yeah, thank you so much for this opportunity. I had a lot of fun, and thank you everyone who showed up. I appreciate your time.
Yeah, I want to thank everyone for coming today. We're going to be we have this recorded today, and I'll be posting it to the website so we can view it again and share it with other people. That I'm sure that, like at work, people actually come to me and say, "Where are the webinars?" And I just tell them where they are, and they go watch them, and they get some value, which is great. So
yeah, watching these things after the fact is awesome.
Yeah, I mean, so when you have time, you might have missed it, and anyway, you get to see it, so that's great. Thank you again, Jeremiah. I guess we'll just end it now, and I'll be at PASS. Are you going to PASS, just curiously?
I am speaking.
Oh, great. I'm going to come check you out. See, what are you speaking on?
I'm giving a presentation about dynamic SQL and how to do it correctly.
Oh, that's cool stuff now.
Yeah, I love it.
Yeah.
I will love it. Well, awesome. I will see you there. Come
All
on
right,
up and
see you
introduce
there.
yourself.
Yeah, thank you. Okay. Y'all have a great weekend, and have fun. Talk to y'all later. Bye.
Thanks, guys. Bye.